minus 0, then I get a, in this particular case, it's a 6, right? Okay, same, you try to times these two, okay, with the, if the lambda here, you know the lambda here is a 2 to the 3 for this particular case. Therefore, when you times also, you should get the same, okay, you times with this, the determinant of this should be same as times. Okay, when I use this as a times, you can see lambda 1 times with the lambda 2, which I get a 6. Okay, therefore same. This is the property number 2 is saying. Okay, another properties of that is eigenvalue. Eigenvalues A. Okay, A must be equal to eigenvalues AT. Okay, you transform or transpose, you should get the same. Okay, number 5. There is a lot, lot to teach you in this case. For all eigenvalues A are non-zero, non-zero, and if I take it determinant is not 0, that means it's not a singular. A is not singular, non-singular, singular, else is singular. Singular. For all eigenvalues A are non-zero. If it is a non-zero, the determinant may get a 0, or A is a non-singular, else is a singular. That means this is singular. Remember, okay? Okay, I'll get back to this one later. 6. Okay. You won't use all these logics lah. You never learn also. I don't know whether you will learn on this. Okay, you take the inverse of that lambda, you get a 1 over lambda, then it can be reversed. Okay, reversed of this. Okay, you get back similarly the characteristic polynomial. I can teach you very advanced. Normally I won't go to detail. Am I going to detail? I don't know. Okay, I think enough lah. Okay, I think you won't go too detail about this. Okay, okay, I believe this is enough for you for the examples that I wanted to explain to you. Okay, there are a lot of logics to teach you. I enjoy this portion to teach. Okay, but okay, anyway, the most important thing is you should master the skills, especially the specific properties of eigenvalues up to whatever that I taught you. Okay, I will come back to this one. You see, I will give you one example first. Let us do some simple example. For example, the A is given 3 by 3, 3, 1, 4. Most of the questions you will get 3. Okay, 0, 0, 5. Okay, you are required to find out. Lambda value. Okay. Okay, how to find out? That means its eigenvalue. Simple. Without further delay, just I will show you very fast how to work on this. First, it's up to you whether you wanted to write in a different way or what do you call the logics depends on the logics that you wanted to build. Okay, take it this one and okay, the model that actually suppose you need to work on this is a okay, see, I create that. Once I create this way, okay, lambda minus 3 1 4, no changes in the rest. This is 2 lambda 6 0 0 5 lambda minus 2, very sorry, because we are doing the other way around. Okay, 2 lambda minus 5. Okay, when I simplify this, this is a little bit easier because it's a 0. I already this is your skill of determinant, to find out. Otherwise you waste your time. Okay, you cannot use your calculator, for sure you cannot use your calculator, right? Okay, since over upper triangulation and lower triangulation that I explained to you before, okay, you just times this, you get the determinant. Okay, in this case it's a 3 lambda, okay, lambda 3 lambda over 2 lambda 5 equals to 0. Okay, therefore you will get 3 logics here. Okay, some of you argue, sir, can I change the other way around? I leave it to you again. Okay, sometimes you get a negative. Okay, you need to manage by yourself. Okay, but in this case this is easy. I have chosen the easiest also. If the lambda is in this case is a 3 2 5, there are 3. Is it make sense to you? Okay, why is a 3 by 3, n as a 3, and you get a linear. Okay, now you check the properties first. We very quickly we check these properties whether it makes or not. Unfortunately the logic is still 0 0. I need to change bit, then only you will see something different value. This one is look like all same, therefore you might think, oh, very easy, I can find out 3 2 5, then it become a lambda value. No, in this particular case, okay, the example that I have chosen is exactly easy one, because the reason I choose this, I'll show you, because I want to show you how to find out the eigenvector. Okay, the reason I choose the simple one first, because how to find this thing is not to show you the eigenvalue. The logic of eigenvalue later become very complex. I'll show you. Okay, let me show you how to get the eigenvalue or eigenvector. Okay, eigenvector. Can I choose the same place? Can, because it's not saving paper, but just for you to see the things beside, side by side. Okay, it's easier for me also to show. Okay, now if lambda equals to 3, okay, if I set it lambda equals to 3, can you see the lambda is equals to 3? Then the logics become something different, you can see. Therefore, if lambda equals to 3, the first these things become 0 1 4 0 negative 3 means is 1, still no problem. Okay, still no problem, your logics will not be affected. 0, okay, 0 0 3 negative 2, okay, negative 2, this become x1 x2 x3 equals to 0. Okay, once you work on this, is something very interesting to find out. Okay, you see this is first one is negative 2 equals to x3, alright. Okay, negative 2, okay, you times with the x3 equals to 0, because if you don't get it clearly, this is, I just write like that, it's easy. Okay, 0 is not a single 0, it can be a 3. Therefore, for sure x3 is a 0. for sure x3 is a 0. Okay, if it is x3 is a 0, can I say that the second one also is a 0? Okay, now that is the predictions that you may have. X2 plus 6x3 equals to 0, right? Okay, when you use the second one, you get a 0. Therefore, what about the we know x3 is a 0, then x2 is a 0. Wow, is it all can be a 0? Cannot. In any circumstances, it all cannot be 0. Okay, you must remember. Okay, what about the next one? Next one is x1. Is it times with the 0 disappeared? No x1 here. Then how to guess this? Therefore, if x1 is 0, you cannot guess that, right? Okay, you cannot guess. Therefore, once we don't know, we just say it's arbitrary. Okay, it's arbitrary. You see, 0 times with any value here, you get 0. That can be, it can be 1, 2, 3, 4, arbitrary value. Therefore, for the overall, in this case, your value here become x1, x2, x3, and for sure x1 you leave it x1 and the rest is a 0, 0. Therefore you take it, this is arbitrary, therefore your value become 1, 0, 0, and this become, for example, if it is a t where t is equals to x1, if I say, and okay, we have done the first portion. Okay, we have done the first portion. Okay, still not get it right. Some of you, not get it lah. Not that clear. Okay, we go for the x2. Okay, we see why I choose the simple one, because I want you to understand this portion. Okay, the eigenvector for this. See, it looks simple, but suddenly it's a 0. I may think, it's also 0, but actually it's not 0. Okay, once it's become 0, it's all trivial. You cannot solve the problem already. Okay, what about the next one? If it is a lambda equals to 2. Okay, if lambda is become a 2, you can see the whole equation become like this. Okay, -1, 1, 4, 0, 0, 6, 0, 0, 6. Okay, what about the last one? 0, 0, -2. 2 is a -3. Okay, something same, is it same? No, it cannot be. Okay, you see, x1, x2, x3, okay, equals to 0, 0, 0. Okay, again x3 is a 0, understood. Okay, can I say x2 is a 0? Cannot. I cannot say anything about x2. Okay, x2 is we don't know. Okay, it's arbitrary value. Therefore, we know x3 is a 0. Okay, then we worked on this. Therefore, you get a x1. The first one is how the first one become a -1. Oh, hold on. Is it a -1? Yeah, -1. Okay, -1. Okay, x1 plus x2 plus 4x3. Okay, equals to 0. Okay, then but we know x3 is a 0, then you just eliminate, then you will have here x2 equals to x1, right? Therefore, can I make the equation back again? Okay, you see the equation, I create back x1, x2, x3. Okay, we know x3 is a 0, just we can write, and you can choose x1, either one of this. Okay, x1, okay, now this become 1 1 0, and if you let t become x1, then you get a x1 or t, sorry, t, but you need to define a t equals to a member of real, but t cannot be equals to 0. That means we get a new vector, eigenvector here. Okay, we get a new eigenvector. What about lambda? 5. Can you see? A little bit tricky, right? Okay, this one not yet. Later you will see. I'll show you more complex one. Then you may find it, it's like. Okay, in this particular case, lambda is equals to 5. Then when it become lambda equals to 5, let me write again. Okay, let me write again. Just 5 2 1 4 0 5 3 6 0 0 0. This is something very interesting. x1 x2 x3 equals to 0 0 0. Okay, and in this particular case you cannot predict what is x3, impossible. Therefore you have another choice here, the relationship to identify. Okay, the first one is arbitrary, you cannot touch this. Okay, for sure this one is a one value that you can represent, but you can find out the relationship within this x2 and x. Therefore you can pick either one of these, no problem. Okay, 2 here, but most important here, this one. Can I use this one to predict this? No point, because it's a 0. Okay, it can represent any value, therefore you cannot claim anything here, you see. But most important here, this one, this two, the relationship here. Therefore 3 relationship okay, first 2 x1 plus x2 for x3, and the relationship within the this one 3 x2 plus 6 x3 equals to 0. Okay, you see sometime here we get a negative here. There's a negative, not good value. Okay, is x2 is a negative to x3. Okay, that is the one logics that we have here. Okay, then when you substitute here is a 0. Okay, when you substitute x3 x2 with this, you get a both something like that. x1 negative 2x3 plus 4x3. Okay, you get a 2x1. Okay, 2 plus 2x3 equals to 0. We get a something x1 equals to negative 2x3. Okay, this one, the relation is a 3. Okay. Something, let me analyze the things. Am I made a mistakes here? No, 2 negative 2, then if I made a mistakes, please correct me if I made a wrong something is it's not in a correct position. Okay, in this case is x1, the relationship between this x2 and x3 we don't know, but we can see represent still same results here. Okay, so 2, yes. Oh, 2 2 2 2 2, yeah, this 2x1 is there. Okay, I substitute 2 here. Okay, yes, okay, thank you. That means it's yes, x1 and x3, correct. Okay, that means the relationship is a negative x1. Okay, now let me build this whole thing. What is the potential for me to get the results of this? If I say x1, x2, x3, okay, the x1 can be represented with the all x3. Okay, you see I represent this with the x3, therefore I get a negative x3. I'm making this one x2 is a negative 2x3. Of course x3 is x3, we cannot touch anything. Okay, therefore you get something very different results here. Negative 1, negative 2 and 1, which is normally it's not preferable. Okay, negative is there, then we can't touch that anyway, and is a t, if you call it that as a the logics in this case is a okay, because I small changes that it causes a lot of problem in this case. Actually it's not a problem anyway. Is that will be any difference in this scenario? No, then I just substituted. Okay, yeah, this one I didn't make mistakes, huh? Okay, negative. Okay, correct. You see, this is what the eigenvalue and eigenvector of this. Okay, therefore you write the whole thing. When you write the whole thing, you will get a very different these things. It's a lambda equals to 3, the eigenvector of lambda 2 is there. 3 2 done, huh? 3, what about 3? 3 is there. Okay, 3 is a 1 0 0 eigenvector. This is eigenvector. Okay, eigenvector for that is this. For the lambda equals to 2, the eigenvector is this 1 1 1 0. Okay, is a lambda 5. The eigenvector is negative 1 negative 2 1. Okay, something different. Okay, you can see different unique is a unique lambda, unique different answers. Okay, is it fulfill the explanation earlier, right? Okay, as I say, if it is unique, then you're supposed to get a different. See, if n distinct eigenvalue, n distinct linearly independent eigenvector. Okay, in this case, can you see that? Okay. Oh, okay. Now okay, what are we going to do? We're going to analyze it based on the some of the cases that I'm going to explain to you. Now we go for the complex scenario. Okay, complex scenario, which I will explain to you few cases, how to find the eigenvalue and eigenvector. Okay, eigenvalue, some of the examples I just make it. Okay, A. This time you can see that what I wanted to say lah. 1 1 1 2 1 0 0 1. You see there is a combination. Okay, what I can say immediately on this, okay, if I add on this 3, okay, if I add on this 2 plus, where is the pen? Okay, if I add on this, the eigenvalue must be same as that. Okay, the first question is simple for you to verify. See, 2 plus 1 must be, the total of diagonal must be same as the eigenvalue that we're going to get later. It must be same. It's a 5. Should be. Okay, should be. Therefore, this is I. Oh, sorry. Okay, sorry. Then you can see that, okay, the eigenvalue, I add on to this. Suppose I should get the logics. Okay, you can see now how A2 minus, okay, I leave it to you to do it, but I just show, okay, equals to 0. Can you show that? Okay, if the case is 2 lambda, or you want to use it a different, up to you again. I leave it to you. 1 2 lambda 1 0 0 1 minus lambda equals to 0. Okay, therefore you cannot times this, because you need to work one by one, step by step, to calculate the whole thing and to find out. I'll give you the lambda answer. The lambda answer is 1 1 3. Can you see this and check with this 5? See, not the same. There is a repeating here. Repeat the value, which is, you can see in this case is a 1 plus 1 plus 3. Are they same? Yes, must be same. Okay, you wanted to find out the determinant of this, you times all these things. Once you times with this all the lambda, you get a 3. Then for sure I know when I take a determinant of this, I should get a 3 as my determinant as a solution. Okay, this is very interesting to identify easily when we use this. Okay, now let us proceed for the lambda. If the case is a 3, let me choose, because this one is repeating, therefore I'm on hold. Okay, this one 3. Okay, if this is the case, always I make a mistakes. Not the same mistakes, because I have done in a different way. Okay, I change it this into this way. Lambda I A is 0. Okay, in this case it works differently. What is the different? Are they different? No, it's for the your convenient again. 2 1 0 0 1, lambda minus 1. Sorry. Okay, I'm going to use this one. Okay, I'm going to use this one for the solution. 3 2. Are they different? 3 minus 2, or this one? Sorry. Okay, I will use this. Okay, I will use this one. It's easy. Okay, same. Okay, I'm saying it's the same because depends for the convenient, as I say when I work on that. Okay, I just choose this one. If it is lambda is 3, then I get a 1 1 1 1 negative 1 1 0 0 negative 2. Okay, now I choose x1 x2 x3 equals to 0 0 0. Okay, if this is the scenario, what is the possible answer that I may get? x3 is a 0. x3 is a 0. Of course, then we know negative x1 equals to x3 plus is a 0, therefore both are same, x1 x3 x2 sorry, x2 therefore both are 0 as well. Okay, 0. X2 is a 0. Can I then what about the rest? 0 0 all 0, we end up as a 0. Cannot be. If this is the scenario, the possibilities, oh sorry, I missed this, very sorry. Okay, if it is x3 is a 0, I missed this one. Okay, I missed this one is x1. Okay, x1 x3 is a 0, therefore x1 equals to x2. Sorry, this is correct. Okay, x1 equals to 0, therefore I make a whole equation for that. The equation become like this. Okay, x1 x2 x3, therefore x3 is a 0, x1 x2 is the same, therefore I can make it as one of this. Since I can make it x1 equals to t, therefore I get a 1 1 0 and t, where t, let it be r, and t is not equals to 0. Okay, 1 settle. Okay, settle. What about the next? Okay, we go for lambda equals to 1. If lambda equals to 1, you get a 1 1 1 1 1 1 0 0 0. Wow. If this is the scenario, okay, you can see x1 x2 x3 equals to 0 0 0. Okay, you have only one, x1 plus x2 plus x3 equals to 0. How to sort out this? Okay, please focus bit, this part, very interesting. X1 can be represented with negative x2 minus x3. Okay, look at this. Now let x2 be a s and x3 be a t. Okay, you now I just place back again x1 x2 x3. Okay, what is the relationship? X1 can be represented with the x2 minus x3. Okay, x2 is a x2, no problem, x3 is a x3, right? Okay, now you see I split this. I split this portion. I will have all one, and the another one portion is there, and negative x2 x3 minus x3 0 0. Okay, therefore if I substitute x2 for the these things, what you call as s. Okay, now there is only one small changes that I need to be very careful. Okay, and we know in this portion when we work with that, here I bring it this side. Okay, x3, all x3 I gather to this side, and just the x2 I put it as a 0. Okay, still same. Oh, you may say, sir, this is a negative, therefore I just say, okay, can I? Okay, now you look at this one. Here x2 is a negative 1 1 0 s plus this one x3 is a t 1 0 1 s. Wow, it's not straightforward, right? You have t, sorry, t, okay, t, and we can just define as s not equals to r, and s is not equals to 0, and t is member of r, and t is not equals to 0. Can you see how complex it is? How complex it is? It's not a straightforward, right? It's not a straightforward. The solution is something very different. Okay, I'll show you 2 more examples. Then after that, we close the whole topic and chapter and the whole course as well. Okay, because my battery going to finish. Then I going to my the camera battery. Therefore, there are 3 more examples to cover. Give me a few minutes. Okay, we will take a break for a while, then just